Hello everybody, welcome to this afternoon session on risk governance. We are very glad to be attending and being presenting at the, as I was calling it, virtual Venice Nano School. And what we are gonna have in mind for you today, this afternoon, is to make this bridge from risk assessment or management, which we have just heard about in the past session, to the social dimension of risk governance. So let's do this bridge together. I'm, by the way, also the chair of the working group A of the Nano Safety Cluster on training, communication, and education. And if you are interested in our program, stay tuned with us. Join the mailing list of the Nano Safety Cluster working group to get more information. So this is going to be on stage for the next 90 minutes. So we are going to have an introduction into risk governance and have an interactive session. So please work with us in using the discussion forum on what risk governance is different from risk assessment or risk management. And then we are going to have a kind of a data block. So we look into scientific and technical assessment, which is requiring data from the scientific community. So make your data fair and also take care of quality assurance, quality control of data. And this is also going to be the topic of the KaRL concept. So we are introducing you to KaRL. A new concept which is just at the edge of emerging, and we are going to, in an interactive session, apply KaRL. Judge a couple of data sets and look on how mature these data are and how relevant we can deduce information from such different data sets. In the end, big block on the social dimension, as this is a very important issue of risk governance, which we will see. And there will be also a kind of an interactive part of it, where we look into a couple of different stakeholder views that we might come across in different cases. Good, so hopefully we get a good take-home message for all of us and enjoy the show. And now we're gonna start with the first recorded presentation given by Sabine Hofer from the University of Salzburg.
Hello and welcome to the talk on risk governance and its application on nanotechnology. This talk will explain why risk governance is far more than assessment and management of risk. Risk at the time of emergence is associated with risk characteristics, and the initial perception of these characteristics refers it to a category, but the categorization might be transient and evolving over time during the life cycle. A risk can be simple and managed by routine strategies and decision-making, or being a composition of risks, thus being more complex and requiring risk-informed and robustness-focused strategies. Bounded knowledge, data gaps, and poor data quality may classify a risk as uncertain, increasing the appropriateness and precaution-based strategies. Finally, ambiguity implies the demand for risk absorption and resilience-focused strategies. An analogous escalation is needed at the site of the risk discourse. Simple risk can be targeted by an instrumental approach, while uncertainty and ambiguity need broader participation of stakeholders. The multidimensionality of risk, the complexity and variety of strategic options to deal with risk, and the mandatory scientific and social discourse cannot be covered by the means of traditional risk assessment and management. Hence, a cross-linked or circular approach overarching the risk life cycle is indispensable. This endeavor is termed risk governance and is summarized by the International Risk Governance Council IRGC as follows. Governance includes all the actions, processes, traditions, and institutions by which authority is exercised and decisions are taken and implemented. Good governance is based on participation, accountability, transparency, responsiveness, equity and inclusion, efficacy and efficiency, and the rule of law. And Risk governance applies the principles of good governance to the identification, assessment, management, and communication. The Irtc risk governance model absorbs risk management and risk assessment within two hemispheres: the assessment sphere, where the generation of knowledge is the predominant task, and the management sphere, where decision-making and implementation of actions is the focus. Risk appraisal, the centerpiece of the assessment sphere, targets knowledge generation on the technical aspects of risk by means of classical risk assessment and by concern assessment, addressing questions of a wider political context and afflicted stakeholders. Risk management, the centerpiece of the management sphere, supports decision-making and subsequent implementation of appropriate measures. However, this model already unveils the need for shared tasks because pre-assessment has to be involved in both domains, thus linking the management sphere with the assessment sphere. The same can be said about the tolerability and acceptability judgment, where risk characterization, a task of the assessment sphere, is bridged to risk evaluation, a task of the management sphere, thus either concluding the appraisal phase or marking the start of the management phase. Risk communication finally cross-links all tasks, suggesting the need for core functions and supporting tasks. Based on the Irtc procedural framework, an advanced nanorisk governance framework, NRGF, was established by the Horizon 2020 funded NanoRico project and presented by Arthur Semanen and his work package team. 6 steps arranged in circular order and supported by core functions are the main characteristics. The unique selling proposition of the NRGF is the perspective of user guidance for all 6 steps, managing the variety of questions and different levels of capabilities of expert and non-expert stakeholders. The NRGF integrates validated methods and tools that are proposed to improve available practices for safety and risk management. The users of the NRGF can directly access high-quality data that are fit for purpose and propose resources such as tools and methods. Let us now walk through the individual steps. The purpose of pre-assessment is to frame the risk, to place an early warning, and to prepare for handling the risk. Pre-assessment involves relevant actors and identifies potential stakeholders groups for subsequent inclusion. It has to capture the various perspectives on the potential risk, but also its opportunities and strategies for addressing it. Pre-assessment is setting the stage in the risk governance process. Erroneous decisions at this point of framing are the most critical because here the agenda for the subsequent steps is defined. Scientific technical risk assessment. The purpose of this step is to perform an analytical and technical assessment and to collect existing information about nanomaterials hazards, exposure and vulnerability of affected populations. Probability of occurrence and extent of harm and severity of consequences must be assessed through appropriate models for human and environmental risk assessment. Risk assessment synthesizes the knowledge base for subsequent decisions, including what options are available for preventing, mitigating, adapting to, or approving the risk. Information for risk assessment studies is provided by particular safety studies and agreed upon methods, but due to the complex nature of nanomaterials, these may be finally insufficient for an unambiguous risk assessment outcome. Concern assessment has to identify the opinions, perceptions, and concerns of directly affected stakeholders, but also the socioeconomic impact and economic benefits or harm of indirectly affected populations. Uncertainty in the context of new technologies raises the bar for the acceptance of nano-based products because human behavior and decision-making is driven by bounded rationality. This makes clear that inclusiveness, being heard, and informed participation of relevant stakeholders is the key in this stage. Information is the key to align perception-driven decisions with decisions based on the outcome of a technical risk assessment. Risk evaluation is a phase of reflectiveness and accountable judgment, reviewing and weighing the outcome of pre-assessment, technical risk, and concern assessment with criteria accepted by science and society. It collects and summarizes information of all three preceding steps and reflects it from a decision-making perspective. The final target is to prepare a foundation and to propose a strategy for the risk management phase, which can be led either by the principles of precautionary or being dominated by the strategy of risk acceptability, risk sharing and mitigation, hence enabling responsible innovation. However, acceptability is frequently a matter of trade-offs between risks and benefits on a qualitative scale. Risk management is a process that addresses the treatment and regulation of a risk by development and implementation of the actions and remedies required to avoid, retain, reduce, or transfer the risk. For standard risk, standard management instruments are frequently available and have to be appropriately evaluated, selected, and adopted. However, sometimes an accepted and harmonized approach is not available. Thus, the design and generation of new risk management options may be needed. An implemented risk management strategy has to cover the whole risk lifecycle, thus is made to last. Monitoring of risk, monitoring the implemented risk management strategy and measures is critical, in particular to keep up with an evolving technical and regulatory environment, changes in the societal perception and tolerance to risk or increasing uncertainty or ambiguity on emerging new evidence. A flexible governance process allows the integration of new concerns and findings in a transparent, fair and fast manner by regular feedback to and collection of feedback from all participating stakeholders using methods provided by the NRGF core functions for communication. We hope this gave you a helpful insight into risk governance and would like to thank for your interest. We would also like to express our gratitude to the funding authority Horizon 2020 Research and Innovation Program. Thank you.